Hello folks, today we are going through this interview question asked by many tech companies. We are given an n times n two-dimensional matrix. We need to rotate the matrix by 90 degrees clockwise. We must rotate the image in place. That means we must directly modify the variable without allocating extra memories. Rotate the image by 90 degrees. That means the first column will become the first row and the first element will become the last element. And for the second column, it becomes the second row. The third column becomes the third row. If you are familiar with the matrix operation, this question can be done using the transpose and reverse. Let's first transpose the matrix, and then we will reverse each row. First, let's see how we can implement transpose in Python. Obviously, you can use the Python library, but it is a good practice to write the code from scratch. So if you draw the line of the diagonal, you can see that transpose it actually means interchanging the two elements on the both sides of the diagonal. So 2 will be interchanged by 4, and then 7 will be interchanged by 3, and then so on. If you're looking up for the coordinates, you'll find out that it's actually interchanging the coordinates from 0, 1, that means from the first row, second column. And this is the second row and the first column. And for the other two, this is 0, 2, and this is 2 and 0. So obviously you swap the value from I and j to j and I, and vice versa. And this is the whole Python code that we can transpose the matrix. Notice that every time we only need to traverse based on the diagonal. So the first row, the second row, and the last row. And that's the reasons for column index j. It starts based on the index I. And the way we reverse is by putting a midpoint here and we swap the value. If the length of the row is even number, you can split the array into two halves and then you swap the values. In Python, the double division, that means round down. So 3 double divided by 2, that is equal to 1. And then 4 double divided by 2 is 2. The n minus j minus 1, that means the last index based on the j. So if the j is 0, that means the last index is 3. If j is 1, that means the last index, that means the second last index, which is 2. The time complexity of this approach is equal to the number of the cells we have. So it's equal to LM. If you like this channel, please click and subscribe. Thank you.